Hi everyone. I would like to make sure that we don't forget about what all these derivatives are good for. So this last chunk is applying our new shortcuts to problems that have a little bit more going on, like questions about tangent lines or word problems, things like that. So if you're feeling comfortable, this is another one where absolutely you could try and just zip through these and then check your answers to see if you're getting it. And then I'll walk through so that you can double check if you missed anything. Okay, so first question is to find the slope of the tangent line to h of z equals the square root of z plus 1 over z at the point where z equals 4. Okay, so again, we know about tangent lines. The question is, how do we tie that in with all this new shortcut stuff? And the answer is, to find the slope of a tangent line, you need to find the value of the derivative at z equals 4. And what we know now is there's an easy way to take the derivative of this thing. So it'll require a little rewriting. So this is just the function. H of z, a square root of z we want to think of as a z to the 1/2. And then a 1 over z we want to think about as a z to the -1. So when we take the derivative, it's a sum, and each term, each prime of z, is just a power rule. So we get a 1/2 z to the -1/2. And then here, the -1 drops down in front, so we get negative z to the -2. And you can rewrite or not here. Our final goal is to plug in the 4. So if I find h prime of 4, I have 1/2 times 4 to the -1/2 minus 4 to the -2. And it looks like I'm going to end up having to do some of that power work anyways just to figure out my answer. So that's 1/2 times 1/2 actually. 4 to the -1/2 is the same as 1 over 4 to the 1/2. And 4 to the 1/2 is 2. So 1/2 times 1/2. And then 4 to the -2 is the same as 1 over 4 squared, which is 1/16. So we have 1/4 minus 1/16. Let's see, so if we make that 16ths, we need another 4 in there, 4 over 4. So we have 4/16 minus 1/16, which is 3/16. Okay, so there's the slope of the tangent line. So we know derivatives give us slopes, and now we know quicker ways to find derivatives. Part B is a word problem. We have a function that tells us the population of cells in some sort of sample. Let's see, total. Okay, so this is population in millions. So this is millions of cells as a function of the number of days. We are supposed to determine the instantaneous rate at which the population is growing on day 4, including units. Okay, so if we want to know the instantaneous rate of change, that should read to you as derivative. So our very first step should be find the derivative of this function. It's written in a fairly nice way. It's a sum, so we'll look first at the 2 times 1.37 to the t. That's a constant multiple, so the 2 is just going to hang out. And then 1.37 to the t is exponential, so we'll have the same thing, 1.37 to the t, multiplied by the natural log of 1.37. And then we get plus the derivative of 32, but the derivative of 32 is 0, so we really have plus 0. Okay, and then we want to know, t is measured in days, we want to know what's happening on day 4. So we really want p prime of 4. Ooh, we hope that Maya brought a calculator. And maybe have batteries. No. Okay, here we go. Phone calculator. Maybe. Ooh, that kind of shows up. Okay. So we have 2 times 1.37 to the 4 times the natural log. I know that's in this one somewhere. There it is. Natural log of 1.37. Okay, is 2.218 approximately. All right, so we had 2 times 1.37 to the 4 times the natural log of 1.37 is about 2.218. Okay, so this just said include units, but I'd like to talk a little bit about what this means. This means that on day 4, the population is increasing by about 2.2 million cells per day. That's the rate. So this is 2.218 million cells per day. Okay, is the population growing at an increasing rate or a decreasing rate on day 4? Okay, so we know it's growing. It's increasing by 2.2-ish million cells on that day. We want to know if it's speeding up or slowing down is what that is asking. Is this rate increasing or decreasing? So to find that, you would have to take a second derivative. So if we do a p double prime, here's our p prime, and we are taking the derivative of that. So that looks really hairy, but it's actually not so bad. All of this stuff, here, let me grab a color. The 2 and the natural log of 1.37, that's all constant. There's no variable in any of that, and it's all multiplied by this little exponential function. So I'm going to have a 2 times the natural log of 1.37 just coming along for the ride. And then I'd multiply by the derivative of 1.37 to the t, which is 1.37 to the t multiplied by yet another natural log of 1.37, which you could write out at the end, but I'm just going to put a square here. We have 2 of those that are getting multiplied in. And we want to know what's going on day 4. So we need 2 times the natural log of 1.37 squared times the 1.37 raised to the 4th power. Okay, that should be easy enough on here. Okay, so where do I need? I'm going to go back here, one more even, and throw in some parentheses, and we're going to square it. 0.698. Okay, so this is about 0.698. That's million cells per day per day. So basically, I think the key thing here is just that it's positive, which means that the rate of change, the growth rate, is increasing. So we expected it to increase by about 2.2 million cells on day 4. On day 5, we expect it to increase by about 2.2 million plus another 0.7 million. The rate is increasing. So by about 2.9 million cells on the next day. So this is how much we expect the growth rate to increase on day 4. So let me see the word increasing or decreasing. So it's at an increasing rate. The rate of change is increasing. Okay, and then last one is back to tangent line, but this asks for a little bit more. This says find the equation for the tangent line, not just the slope. We have this polynomial function. I think it's the one that was in the last example even. So we can take its derivative. If we want to find the equation for a tangent line, we need to know point and we need to know the slope. And the slope comes from the derivative. So shortcuts on this, say you'll get 4 times 3 is 12. A to the 3rd, there's the power rule, minus 6a squared plus 7 times 2 is 14, a to the 1st minus 1. Okay, so p prime of -1, ooh, I probably don't even need a calculator. -1 is nice. So we're going to get -12 right here. And then -6 times it's minus 6, and then 14 times -1 minus 14 minus 1. Okay, so this is -20, 32, -33. We also need a point, so this is our slope. We also need a point, and to get the point, we need to know p of -1. So the function gives you y values, the derivative gives you slopes. If we plug -1 into the original function, raising it to a 4th power makes it positive, so we just get a 3. Cubing it, still negative, so negative 2 times negative 1 is plus 2. 7 times negative 1 squared is just a 7. Minus a negative 1 is plus 1, plus 12. Okay, so I have a 10, 12, 13, 25. So the point is negative 125, which means the equation for the tangent line is going to be y minus 25 equals slope negative 33 times, I guess our variable is a, so it'll be a minus negative 1, a plus 1. So y is equal to negative 33a minus 33 plus 25, or negative 33a minus 8. Okay, so expect to see a lot of these problems that are similar to what we did in the first section. We can just use shortcuts to help us get to them now. And when we get to exam versus skills test, these are the kind of questions that go on exams, and just straight taking the derivative and not doing anything with it is the kind of question I would put on skills test generally. All right, thanks for watching.